Hey guys, let's look at these multiple choice questions and see if we can figure them out. Now for question 1, it looks a little tricky that we're trying to evaluate some limit, but if we recall the definition of the derivative, which is the limit as h goes to 0, f of x plus h minus f of x all over h, then this is really just asking us to take the derivative of our function f, which in this case will be cosine, and evaluate it at x, which will be 3 pi over 2. So if our function is cosine, the derivative of cosine is minus sine, so we want to evaluate minus sine at 3 pi over 2. If we look at the unit circle, 3 pi over 2 is the point with coordinates 0, negative 1. So the value of sine at 3 pi over 2 will be negative 1, but we need to take the opposite of that. So 1. We want our first derivative to be negative, so we want our function to be decreasing. We want our second derivative to be negative, so our function to be concave down. Our function is decreasing on this interval, so that leaves us with 2 points to test, either B or C. But since we also want it to be concave down, that leaves us only with point B of having a negative slope for its tangent line and also on a part of the graph that's concave down. So we want to find the slope of the tangent line at this point in our function, or our curve is defined implicitly. So let's use implicit differentiation, and we're going to have to use the product rule here. So the product rule says the derivative of the first times the second plus the first times the derivative of the second. We also need to use the product rule here. So the derivative of the first, 2y dy dx times the second plus the first times the derivative of the second. And the derivative of 6 is 0. Let's get everything with the dy dx on one side and everything without it on the other. So we have 3y squared x plus 2yx squared dy dx, and this is equal to, if we subtract this over, negative y cubed minus, 2y squared x. Now it doesn't matter when we plug in our x and y. We can solve for dy dx and then plug them in, or we can plug them in now and then just divide over. So I'm going to plug in 2 for x and 1 for y. And then if we simplify this, we get 6 plus 2 squared is 4 times 2 is 8 2 times 2 is 4, so we get 14 dy dx is equal to negative 5. If we divide both sides by 14, we can see that it will be negative 5 over 14. Alright, let's draw a quick sketch of what's happening here so that we can get a better understanding. The line y equals 2x, the parabola 2x squared. So if we can find these endpoints, that would help us in knowing when we're taking the derivative from, or the definite integral from. So when does 2x equal x squared? We can solve it like we do all quadratics. When does, there was a 2 here. 0 equals 2x squared minus 2x. Let's factor out a 2x. So this x value is going to be 0. This x value is going to be 1. So we know that we're evaluating this from 0 to 1, so right away we can eliminate these. And now if we think about the line y equals 3, y equals 3 is here. So our outer radius is going to be, of course I picked the wrong color, our outer radius is going to be the distance from 3 to our parabola. So our outer radius is going to be 3 minus 2x squared. Our inner radius is going to be the distance from 3 to that line. And to find the volume will be equal to pi times the definite integral from 0 to 1 of our outer radius squared times our inner radius squared, all with respect to x. And we're going to subtract our outer from our inner. So 3 minus 2x squared is our outer, and 3 minus 2x is our inner. Now, there's a lot going on here, but it talks about inflection points and relative extrema. Relative extrema happens when our first derivative is equal to 0, and there's a sign change. So 4x cubed minus 6x squared. But that could be rewritten as x squared times 4x minus 6. And our second derivative is equal to 12x squared minus 12x, which this can be rewritten as x times 12x minus 12. So now let's think about this. We need to have our first derivative equal to 0 and have a sign change of that first derivative in order for there to be a relative extrema, maximum or minimum. So if we look here, we have x squared. So yes, the first derivative will be equal to 0, but there'll be no sign change of the first derivative there. 4x minus 6, we'll have the first derivative equal to 0, and we will have a sign change. So there's only going to be one relative max or min, relative extrema. And for an inflection points, we have two places where our second derivative will be equal to 0, and both of them will yield a sign change. So we have only one relative extrema and two inflection points. Alrighty. Let me see if I can get some more space on this next one. I think it will be helpful if we rewrite f of x as the sine of 3 minus x quantity squared. That way the chain rule is a little bit easier for us to see. So our derivative will be equal to 2 times the sine of 3 minus x to the first times the derivative of what was inside originally. So the derivative of sine is cosine. So times cosine of 3 minus x times the derivative of what was inside there. So times negative 1. We're evaluating this at 0. So f prime of 0 will equal 2 times the sine of 3 minus 0, or 3, times the cosine of 3 minus 0, which is 3, times negative 1. So we have negative 2 times the sine of 3 times the cosine of 3. Alrighty, last one. We've done a pretty good job on these differential equations, and if we want to find the particular solution, we need to first separate our variables. So y dy is equal to 4x dx. We then want to take the indefinite integral of both sides, and don't forget your constant of integration. So 4x squared over 2 reduces to 2x squared. Now, given this initial condition of x equals to 2, y is negative 2, we can solve for our constant of integration. This, I knew something was wrong. This is a 2. And then 4 squared divided by 2 is 2. And this is 8 plus c. Little math mistakes. Okay, so negative 6 is equal to c. We can now, knowing that c is equal to negative 6, y squared over 2 is equal to 2x squared minus 6. Multiply both sides by 2. And when we take the square root of that, y is equal to plus or minus the square root of 4x squared minus 12. But we look at our initial condition. Our initial condition was negative, so we want to take the negative of our solutions. So our answer is negative square root of 4x squared minus 12. Alright guys, we can talk about this more tomorrow.